So our final presentation in the session is another online one. It is Kepler Watt Store. And if our speaker can hear me, please take it away.
Yes.
Okay.
Hi,
Yep,
folks.
thank you. Hi, this is Parul, and I have with me Christophe.
I'm Christophe. Laprun.
One sec, let us try and turn the volume up a little bit.
Oh.
Is there any chance you could turn your microphone sensitivity up a little?
Okay.
Is it better?
It's very quiet.
Let me check. Can you hear me okay?
Yeah?
I
If you
guess.
could both speak
Is
up a
it
little,
better
or
now?
if you can increase your microphone gain.
I think I'm at the max already, but...
Me too.
Okay. Yes.
I'll speak
Just
louder.
speak loudly, and please take it away.
Okay. So I am Parul Singh, and I work at Red Hat. And well, the talk before this was a great segue to our talk, which is Kepler Watt Store. And
Parul, sorry
what we're going to
you
present.
really are quite quiet. Is there I think our sound is up to the max, so if there must be some way, I think, to get your microphone gain up a little bit higher.
Okay. Christophe, do you want to present while I try to fix my microphone?
Thanks very much. You just sound a little bit far away from the microphone as well. It could just be a case of speaking louder and closer to the mic.
Hi, this is Nicola, but I can hear her perfectly on
Okay,
Discord.
you can hear them perfectly online?
Yes?
Yeah, the sounds fine online.
Yeah.
Okay, so is it okay for me to continue?
Yeah, I think, I mean, things are a bit quiet here. Parul, if you just speak as loudly and closely to your microphone as you can, and that's the best we can do. Thank you.
Okay, I am on my headphones, so I'm trying my best. Okay. Let me just see. Give me a second. Yeah, my headphones sounds at the max. This is the best I got.
No, it's really
Anyways,
good.
I'll try my best.
You're almost too loud. So that's perfect. Thank you so much. You can continue. We can hear you really well now.
Okay, sounds good. So Christophe and I are going to present Kepler Watt Store, which is a collection of open source cloud native tools that uses Kepler as a cornerstone of project. And we're going to talk about Kepler to Watt software power consumption. And I think the talk before us did an excellent job of explaining why we need to do or monitor software power consumption. So let's just get into it. Yeah.
Yeah. So yeah, as the previous talker was saying, it's quite imperative to reduce the power consumption of human activities, and in particular software, because according to Gartner, in 2021, an ACM technology brief estimated that the carbon output of the information and communication technology sector contributing between 1.8 and 3.9% of global carbon emissions. So you may think that's quite small, but to put it in some perspective, the carbon emissions of plane transportation is estimated around 2.5%. And another aspect of that is that those emissions associated with the ICT sectors are expected to grow under the current conditions. And we should also mention that carbon is only part of the equation when it comes to resource consumptions with the ICT sector. Yeah. So what are the problems that we face when trying to measure those things? Because as you see in the estimates reported by the ACM brief, basically the lower range is almost half as much as is more than half as much as the upper range actually. So we need to have a better accuracy on a better handle on the power consumption of our software, because we cannot really impact what we cannot measure properly. So the first question that we need to ask ourselves is, how do we measure energy consumption indirectly? Because we could measure, put a power consumption device on our outlet for our computer, but we want to have a more granular type of data so that we can get information on a per software basis. So for that, we need to be able to measure consumption indirectly. And ties into the second question is, how do we measure energy consumption of workloads when it comes to cloud native workloads, when you don't have direct access to the hardware, and oftentimes the software runs into virtualized layers, which further hide the hardware details. And speaking of which, so how do we attribute power consumption on shared resources to specific processes, down to containers when running on virtualized systems and Docker-like environments, or pods in Kubernetes type of clusters? Another idea also is to try to surface that information as early as possible in the software development lifecycle, because once you get your application deployed and running in production, it's hard to make any changes anymore. So you want to be able to react as fast as possible in the life cycle of your application to energy signals. And then last question, which we won't tackle in this talk today, but which is quite significant as well, is, how do we move from energy consumption measurement to carbon emissions? So I'll switch back to Parul now.
So before we dig deeper into the projects, let's just quickly explain who we are. We are a group of people who are working or taking a community-based approach on environment sustainability. And if you're not aware, we are part of Cloud Native Cloud Foundation tag Environment Sustainability. And together as a community, we try to advocate for, develop, and support and help evaluate environmental sustainability initiative in cloud native technologies. And we try to identify values and possible incentives for service providers to reduce the energy consumption and carbon footprint through cloud native tooling. And Kepler, which is the cornerstone of this whole ecosystem, is now a CNCF sandbox project. And we go to the next slide. And we are also have multiple projects associated with Kepler that you're going to see in the coming slides. So what essentially is Kepler? It is a Kubernetes-based efficient power level exporter. And what it does is it uses software and hardware counters to measure power consumption by hardware resources and exports them as Prometheus metrics. It does three jobs. It does the reporting at per pod energy level consumption, including various hardware resources like CPU, GPU, RAM, and it supports both bare metal as well as virtual machines, which Christophe already mentioned that most of the cloud technologies, they use virtualization where you don't have access to the actual servers. So you have very limited access to what is going behind those virtualization. So Kepler does a great job in supporting both bare metal as well as virtualization or VMs. And it supports Prometheus metrics, which is quite the standard of cloud native. And most of systems are compatible with Prometheus metrics, so you can easily consume the metrics exported by Kepler. This question was raised earlier in the talk, that if you are using a software to measure or report energy consumption, what is the computational footprint of the software itself? You don't want something that is measuring energy consumption to take up like a major chunk of the energy of the system, right? So it's very crucial that we had to keep Kepler footprints, energy footprints, bare minimum. So we use a technology which is called eBPF, and that really minimizes how we are measuring these metrics, because we actually hook up to Linux kernels, and we just read those counters from Linux kernels and export back as Prometheus metrics. So Kepler supports machine learning model to estimate energy consumption, and this comes handy when you're working on a virtualized or VM-based scenarios where you don't have access to the bare metal. So we run a lot of experiments on similar servers, and we develop machine learning models that Kepler uses to estimate what would be the energy consumption of workloads when you don't have access to the underlying hardware. This, I will briefly talk about a whole cloud native sustainability stack with Kepler, which is the epicenter. And with Kepler, we have also multiple projects working. I'm also going to talk about Peaks, which is power efficiency aware Kubernetes scheduler. But there are lots of other projects that's around Kepler, so feel free to check out our GitHub repository, which we have mentioned on the slides. And coming back to the title of this talk, which is Kepler Watt Store. So you must be at this time wondering, what is Kepler Watt Store? And it is a set of open source and cloud native power aware tools to monitor and optimize power efficiency throughout software lifecycle. And it incorporates Kepler and Peaks at various stages from development to deployment. And tools in Kepler Watt Store targets power consumption monitoring at various phases of software development lifecycle. So at the developer's end, we have two research ideas for monitoring power consumption. That is at the time of software development, as Christophe mentioned, to detect components of software that are very energy costly, to identify them and fail before you put this deployment on the production, where it is more expensive to solve problems that are leading to energy leakage. And also at the step of continuous integration, where we are working on building up GitHub actions so that you can compare the energy consumption of your previous deployment versus the current one, and identify if the new deployment is more energy costly compared to the previous one. And again, the whole purpose of introducing this at the developer side is to identify energy leakage at earlier stage and solve them before they are migrated to production, where things are more expensive to solve. While at the infrastructure side, we have Kepler. Back, yeah. We have Kepler that does runtime monitoring of power consumption at the deployment phase. So let's say you have a Kubernetes cluster running, you can monitor the runtime energy consumption of your deployments. And Kepler not only works on Kubernetes, we have also extended it to work on Linux servers. It is compatible with RHEL machines, so you can monitor the runtime energy consumption of your deployments in Kubernetes as well as on Linux servers. And then you have Peaks, which is power efficient scheduling, which does a very intelligent job of identifying various nodes on the cluster that are more energy efficient for running your target workloads. And it selects those nodes within a cluster and runs your deployments on those particular nodes.
Okay, so if we switch back to what we can do in the development phase, as we mentioned already, the idea is to get as early as possible feedback. And we are running currently experimentations with local power measurements during development. We have a prototype in the form of extensions for the Red Hat, for our Quarkus framework, which is a Java-based framework. And this experiment is raising lots of questions because, as mentioned in the previous talk, we need to have platform independence because developers don't necessarily target the same system. as the one that will be running the application in production. So we need to have something that works on Windows, Linux, and Mac OS even. Another question is, how do we get meaningful data from what happens during development? Because the patterns or software consumption that's used during development might not be representative of what will be happening during production. We want to see also to investigate integration with profiling tooling, because that would be really helpful. We see a correlation between performance and power consumption. So integrating at those levels will be useful. And specifically for Java, there are questions with what happens during the virtual machine warm-up and such.
Hi, just
So
to let
that's
speakers
during.
know, there are 5
Yeah.
minutes left in this session.
Yeah, we'll go faster. So we talked about development, what we can do. The next stage in the life cycle is during continuous integration. And as Parul was saying, we can use Kepler there during CI pipelines that run as GitHub actions. And you could envision gating of those actions of those CI pipeline where your software wouldn't be deployed if for example, it wouldn't fulfill some energy budget that you set. And then we can move into runtime monitoring, which is really what Kepler shines, where Kepler shines. Actively monitoring workloads on the cluster as they run, and that provides crucial data for optimization and future software iterations. And specifically, as Parul will talk more about, but with power efficient scheduling with peaks. And back to you, Parul.
Yep. So Kepler does an excellent job at giving you the insights on what is the energy consumption of your workloads. And using this data, we have developed peaks that use pre-trained models that does a correlation between node utilization and power consumption. So the idea is if your nodes are highly utilized, you are saving on idle energy to keep those nodes running, and you are only using the dynamic energy of those nodes. So it is more efficient to schedule workloads in a cluster on nodes that are higher utilized compared to nodes that are less utilized. And the default scheduler of Kubernetes does a spreading job and not and does not does best utilization allocation job. So we had to develop a custom scheduler that takes into account what is the workload requirement, what is the source resource requirement of the workload, and then build machine learning models to predict the best fit nodes that take into account highly utilized node and keep on fitting workloads on those highly utilized nodes until the energy reduction is not significant enough, and then it moves to the next highest utilized nodes, and again does the same iterative job of putting workloads on the next higher utilized node. So that is what Peaks is about. And we have shared the links at the last slide, and so feel free to check out the links if you want to get deeper into each of the softwares or projects that we are talking about. But Christophe can just summarize what the Kepler Watt Store is all about.
Yeah, we saw. Thank you, Parul. We saw that we're trying to take a holistic approach to monitoring power at different stages of the software development lifecycle, and that allows developers and software engineers to take a proactive stance and take into account sustainability into their development. addressing power efficiency from inception to execution, and yeah, that allows us to switch the paradigm of software development towards environmentally conscious and resource efficient software systems. So I don't know if we have time for questions, but
Let's thank our
here's the
speakers.
slide. Thank you.
There was a huge round of applause there. I don't know if you could hear it. We maybe have time for a couple of questions, and Neil looks like he wants to start us off.
Thank you very much. I'm really glad to see the initiative from the CNCF on power management here. Many programming language runtimes have hooks for runtime tracing and events and so on. And it would be really nice, for example, in a language like OCaml, to integrate callbacks from the underlying system below whenever to alert the program about energy spikes and so on and so forth. Do you have any kind of standards or guidelines for programming language implementers to integrate things like Kepler in a portable way, so that it'll work? You know, it won't get in the way if Kepler is not available, but it will just activate invisibly if it is in the cluster.
Yeah, yeah, Christophe, you want to take that?
Yeah, regarding Kepler, it would be difficult because I mean, you would need to have basically a hook for every different kind of languages. Regarding the Java experiment that we are running, that I hinted at that with the integration to profiling tools, but we're thinking about surfacing energy consumption information as part of the Java flight recorder tracing system that exists for the Java virtual machine. And the idea would be that you would see when using your profiling tools, similarly to the percentage of CPU that's being used for a particular method call, for example. The idea would be that you could see the power consumption attributed to that specific method. But at this time, we don't have any more or broader plans to integrate with the kind of. It would be nice indeed, but there's nothing going on at the moment.
Sounds great. So it sounds like an opportunity for new research for people to think about portable.
Yeah, definitely.
Integration. Thank you.
You're welcome.
We maybe have time for one more question before we break for lunch. Oh, we've got one here.
Could you say something about the about experience in the field, as it were, with your tools? Can you talk about the kinds of efficiency improvements that that people have been able to achieve, and the kinds of information that were useful for that?
Yes. So we had just started working on the optimization component using Kepler. So the Peaks project is very, very new, and we are in the progress of creating a KEP, which is Kubernetes enhancement proposal, to propose our scheduler. But we do have lots of work done in the monitoring that is using Kepler, and we demoed at the KubeCon last year of how IBM as well as Intel has been using Kepler to test their new architecture, and how they made the release of how they were able to identify the amount of energy consumption between the previous and the next generation of architecture. So we are very new in the optimization component, but we have been working for a year with Kepler on the monitoring side of it.
We'll have our last question here with Patrick, and then we'll break for lunch.
Thank you very much for the talk. I was wondering if you've got a bit of a roadmap, maybe from moving from kind of power-aware scheduling to emissions-aware scheduling, which is something we've looked at a little bit by taking things like energy grid forecasts, certainly within Great Britain, to look at, you know, maybe it's better to run certain long-running computations, say, in the evening, or anything like that would be pretty cool.
That's Yep. So I presented a talk in KubeCon 2022 regarding the same, where we were following the sun. The talk title was like how you can follow the sun to find or use renewable or like use clusters that are powered by renewable energy. And the challenge that we faced over there, and even Christophe talked about that, the challenge of moving from energy monitoring to carbon forecasting is the APIs or the third-party vendors that give you these carbon data are very limited and they are not very reliable because, for example, we were using electricity maps to generate a carbon forecaster and to give us what is the forecasted carbon emission in certain steps ahead in future. But the issue with those third-party vendor is how they are measuring carbon is not transparent. So you just have to take their word, and most of the time they say it's renewable, but more often they're doing carbon offsetting than actually using renewable energy sources. So I can put my talk link in the chat later. Feel free to find it on YouTube and watch it. But I did present this, and we kind of put a break on investigating in those areas. And now we are working with CNCF and various cloud providers like Google and AWS to kind of find a community approach on what other protocols have more transparency on how these carbon reportings are done so that we just don't have to take words by a vendor, but have like a more transparent and universal approach on how these carbon measurements are done. I hope that answers your question.
He's nodding. He's nodding. That would be great if you could share that online as well. Thank you.
Yeah,
Thank you.
I will share the YouTube link.
Perfect. Great.
Okay.
Let's thank our speakers one last time.